Hello students, welcome to the video lectures of speech and natural language processing. So today we talk about acoustic phonetics and signals. So introduction to acoustic phonetics. Acoustic phonetics is the study of physical properties of speech sounds as they travel through the air in the form of sound waves. It focuses on analyzing the acoustic signals generated during speech production. Basically this concentrates on the the signals that pass through the articulatory organ. Okay, so it focuses on analyzing the acoustic signals generated during speech production. So generally basically the speech production happens using our articulatory organs, which we have seen in our previous video lectures, where and how each letter is being pronounced, what is the role of articulatory organs, and how they are being pronounced, whether they are using glottis or hard palate or soft palate, or either it's a bilabial sound, whether it is a coming up with the sync of the lips or teeth or tongue, whatever. So those all things are considered, and now we talk about this acoustic signals, and it focuses on analyzing the acoustic signals generated during speech production. These signals can be examined in terms of frequency, amplitude, duration, and formats. So when we speak something, all these things exist, right? When we involve our articulatory organs and try to pronounce something, so basically every pronunciation that the word that comes out of the speech, have these things. So these signals can be examined in terms of frequency, amplitude, duration, and formats to understand how speech sounds are perceived and distinguished. Acoustic phonetics bridges the gap between articulatory phonetics, that is, how sounds are produced, and auditory phonetics, how sounds are perceived. I'll just read it again. Acoustic phonetics bridges the gap between articulatory phonetics. Articulatory phonetics are how sounds are produced. That is how the speech production happens. Next, and auditory phonetics. That is how sounds are perceived. Then we talk about speech signals. So when a person speaks, the vocal tract produces sound waves that are time varying acoustic signals. So these signals can be analyzed using various tools and concept. So such as first one is frequency. So definition, the rate at which a sound wave vibrates, that is frequency, which is measured in hertz. So higher frequency, higher pitch sound. So example, a child's voice generally has a higher frequency than an adult's voice. It's about the frequency. Amplitude, the intensity or loudness of the sound wave. So measured as the height of the wave in a signal. Higher amplitude, louder sound. Next is duration, the time period over which a sound occurs. The time period over which a sound occurs. Example, vowels like A are generally longer in duration and compared to stops like T. Next is spectrogram, a visual representation of speech signal that shows frequency, that is vertical axis, time as horizontal axis, and amplitude as color intensity. So spectrograms are key in acoustic analysis to study speech sounds. So key concepts in acoustic phonetics. First one is fundamental frequency. So the lowest frequency in a sound wave where corresponding to a vibration of the vocal cords, which represents the pitch of the voice. Example, a male speaker may have an fundamental frequency which is represented as f of around 120 hertz. A female speaker may have a fundamental frequency of 200 hertz. Next is harmonics. Harmonics are multiples of the fundamental frequency. They occur naturally in voiced sounds. Formants are the resonant frequencies of the vocal tract. They are important in distinguishing vowels and other speech sounds. So examples you can see, F1 and F2 are the two primary formats used to classify vowels. You see now I as in C. So the I which we see in this particular word, that is SEEC, has a high F2 and low F1. Then A as in father has a high F1 and low F2. So these examples will make you understand the about the vowel that has been pronounced in these particular words, which has lower F1 or higher F2, or higher F1 and lower F2. Next is speech waveform. A waveform represents the variation in air pressure over time for a speech sound. used for analyzing duration and amplitude. Next, voiced and voiceless sounds. So, voiced sounds are produced with vocal cord vibration, that is B or D. So, when we say some kinds of examples which includes these particular letters B or D, you can you can see that vibration in the vocal cord. Next is voiceless sounds which are produced without vocal cord vibration, that is P, T or a S. So words which contain these alphabets, you can understand that the vibration doesn't really have that much when we have this with compared with your voiced sounds. Tools for acoustic analysis. So there are a couple of tools which will make this acoustic analysis. So first one is spectrograms. Spectrograms will visually represent the sound waves and are widely used to analyze formants, harmonics, and pitch. Next is Pratt software, a popular tool for analyzing and visualizing speech signals in acoustic phonetics. Next one is waveforms, the tools that display the amplitude of a signal over time. So these are various tools for performing the acoustic analysis. So already we discussed what is acoustic phonetics or acoustic analysis, why we need to do this, what is the importance of this. So generally the uh, sound that has been produced during the speech production. Next, examples of acoustic phonetics. So vowel analysis. So vowels have distinct form and patterns. So I, high front vowel, that is F1 is low and F2 is high. U is high back vowel. So F1 is low and F2 is also low for this. So examples are C and saw. So you can see. Next is voiced and voiceless sounds. Just now we discussed. Next comes the applications of acoustic phonetics in NLP and speech technology. So before this, since I told you we have already seen this, just let me read this. Voiced versus voiceless stops. So voiced stops like B have a lower amplitude and vocal cord vibration visible in waveforms, where voiceless stops like P have higher amplitude and no vocal cord vibration. So we have seen a couple of examples in our previous video lectures as well. So you can see that this B or D containing words will have a vibration in the vocal cord, whereas this P or T something doesn't have vibration in the vocal cord, but which will have higher amplitude. Okay, but these voiced sounds which have this B or D in their particular words will have a lower amplitude. Then applications of acoustic phonetics, we will see now. First one is speech recognition. Yes, acoustic features such as formats, pitch, and waveforms are critical for identifying spoken words. Then speaker identification, unique characteristics of a speaker's voice. So unique characteristics of a speaker's voice in the sense we have been seeing there are a lot of projects that have been coming up. There are a lot of research papers also which exist for identifying a particular speaker when there is some debate that is going on, or it might be in any other platform. So there are a lot of models that have been come up in the market right now where those softwares are being used to identify that particular speaker. Okay, so here you can see the speaker identification using the unique characteristics, that is pitch, formants, and harmonics. This is an important application. Next is text to speech synthesis. Acoustic phonetics helps in synthesizing natural sounding speech using spectrograms and formats. Next is speech therapy. Acoustic analysis is used to diagnose and treat speech disorders that occurs in many of the people. Thank you, students.